In this very lesson, we shall be looking at the binomial theorem itself. In our previous lesson, we learned how to expand a binomial expression using the Pascal's triangle. Now let's assume that you have a binomial expression with a power of 100. So you have the binomial expression, let's say a plus b raised to the power 100. You agree with me that expanding this binomial expression with this huge power using the Pascal's triangle becomes very stressful. This is because you have to find the 100th coefficient of this binomial expression. And in doing that, you need to find the 99 rule of the Pascal's triangle before you can find the 100th coefficient of this binomial expression. And you agree with me that it is not going to be an easy task for you at all. If that is the case, then we need a more powerful method or approach that is going to help us to expand this binomial expression with ease without any stress at all. Then this calls for the binomial theorem. Under the binomial theorem, we shall be considering two methods, the combination method and then the factorial method. So these are the two methods that we shall be looking at under the binomial theorem, the combination method and then the factorial method. So let's start with the combination method. So we are actually starting with the combination approach. And under the combination approach, we shall be making use of this formula. This formula seems very lengthy, but it is very easy to remember. It is similar to that of the Pascal's triangle because in the Pascal's triangle, we were making use of what? Coefficients from the binomial expression. In this formula too, we are making use of what? The coefficients. The coefficient here is being taken care of by the combinations. So this means that the coefficient from a binomial expression can be generated using the combination approach. Now, in the Pascal's triangle, we said that the first term takes the whole power of the binomial expression, while the second term takes a power of 0. From that, the power of the first term decreases in succession, while the power of the second term increases in that order. And this is the same as that. The coefficient is being taken care of by the combination. The first term decreases in succession, while the second term increases in succession. That is what we said when we were dealing with the Pascal's triangle. So there's nothing different about this. Now, in remembering the formula too, it is very simple. Now we have n represent the power, combination 0. So from 0, it moves to 1, 2, 3, 4, and so on. Now the n is always the same, and then the rest follows the pattern from the Pascal's triangle. That is that. So let's take examples and see how best we can apply this formula to expand a binomial expression. So let's take our first example. So we want to expand this binomial expression with a power of 3. So let's do that. We are going to expand that using the combination approach using this formula. So first of all, we have to find the number of terms, and we can do that using the formula n plus 1, where n is the power of the binomial expression. So we have 3. So we have 3 plus 1, that gives us what? 4 terms. So it means that at the end, we should have what? 4 terms. So we know that our n is equal to what? 3. So we are just going to substitute that in this formula, and then we are good to go. So we have 3 combination what? 0. Our first term is what? A. Our second term is what? B. So this is the first term. This is what? The second term. So we have A raised to the power n. So n is what? 3. And then our second term B raised to the power 0. We have our plus. And then we have our n is 3. Combination what? 1. We have A raised to the power n is 3. So 3 minus 1 will give us what? 2. And then we have our B raised to the power 1. So as I said earlier on, the first term takes the whole of the power, while the second term takes a power of nothing. After that, the power of the first term decreases in that order, whilst the power of the second term increases. That is all. So we have our plus. So we have n is what? 3, combination what? 2. Our A, 3 minus 2 give us what? 1. And then we have B raised to the power 2. Very easy. And then we have plus 3 combination. So from 2 we move to where? 3. And then we have A raised to the power 3 minus 3 will give us what? 0. So A raised to the power 0. And then B, from 2 we move to where? 3. That is that. We are done with it. So after that we just simplify. So we have 3 combination 0. 3 combination 0. Now we have already learned about combination in our previous lesson. 3 combination 0 means that we have 3 factorial all over 3 minus 0 factorial, then we have 0 factorial. So we are going to have 3 factorial all over. This will give us 3 factorial multiplying 0 factorial. So we have 3 factorial, 3 factorial. This can cancel that. We are left with what? 0 factorial. 1 over 0 factorial. Remember, by definition, 0 factorial gives you 1. So we are going to have 1 over 1, and that is 1. So 3 combination 0, we have what? 1. Good. So we have 1 A raised to the power 3. And then B power 0 give us what? 1. So we are at 3 combination 1. So we have 3 combination 1. So we know that 3 combination 1 is equal to 3 factorial all over 3 minus 1 factorial. Then we have 1 factorial. So we have 3 factorial all over 3 minus 1 will give us 2 factorial. Multiplying 1 factorial is the same as 1. So you know that 3 factorial will give you 3 times 2 factorial all over 2 factorial. So that at the end, this will cancel that. We are left with what? 3. Therefore, 3 combination 1 will give you what? 3. Very, very easy. So let's do. So we have 3. That's for the combination. And then we have A raised to the power 2, and then B. Then we have our plus 3 combination 2. So we have 3 combination 2, which is the same as 3 factorial all over 3 minus 2 factorial, and then we have 2 factorial. So we have 3 factorial all over 3 minus 2 give you 1 factorial, and then we have 2 factorial. So we know that 3 factorial, we can write it as 3 times 2 factorial all over 1 factorial is still 1. So we have 2 factorial. So you realize that 2 factorial will cancel 2 factorial. We are left with 3. As easy as A, B, C, D. So we have 3 combination 2 give you 3. And then we have A, B power what? 2. And then we have 3 combination 3. So we have 3 combination 3. So we know that 3 combination 3 will give you 3 factorial. And then we have 3 minus 3 or factorial. And then we have what? 3 factorial. So we have 3 factorial all over what? 0 factorial multiplying 3 factorial. We know that 0 factorial will give you what? It will give you 1. So 3 factorial will cancel 3 factorial. We are left with 1 over 1, and that gives you 1. So 3 combination 3, we have what? 1. And then A raised to the power 0 is the same as what? 1. And then B raised to the power 3. Let's do our last simplification. So we are going to have A power 3 plus 3A squared B plus 3A B squared plus B cube. And that is that. Very, very easy. Like as I was saying, the combination takes care of the coefficients. So during the expansion under the Pascal triangle, a binomial expression with a power of 3, the coefficients are 1, 3, 3, 1, and that is what we had, 1, 3, 3, 1. So the combination takes care of the coefficient of the binomial expression. Let's take another example. So we have our second example. We have to expand this binomial expression using the combination approach. So first of all, let's identify our first term. So this is the first term. This is what? The second term. And then our n is equal to what? 4. Let's find the number of what? The terms that we are going to get after expansion and then simplification. So we have n plus 1. Our n is 4 plus 1. So we have 5 terms. So we are going to have 5 terms after everything. So let's start. We have our n. Our n is 4. So 4 combination 0. Our first term is what? 2. So we have 2 raised to the power n. Our n is what? 4. And then our second term is what? Minus x. It will take a power of what? 0. Then after that, we have our 4 combination. This will increase to what? 1. And then the power of the first term will decrease. So it will decrease from 4 to where? 3. While the power of the second term will increase from 0 to 1. So we have minus x raised to the power 1. Then we have 4 combination. From 1 we move towards 2. The power of the first term will decrease from 3 to 2. While the power of the second term will increase from 1 to 2. Then we have our plus 4 combination 2, we move towards 3. Then we have the first term, which is 2. The power will decrease from 2 to 1. And then we have the second term power will increase from 2 to 3. Then we have plus 4 combination from 3 move to 4. And then we have 2 power 0 minus x raised to the power 4. As easy as A, B, C, D. You don't have to memorize anything. Just follow it. It will come by itself. So let's do the algebra. 4 combination 0. it is surely going to give you 1. So we have 1, and then 2 power 4 will give you what? 16. And then this will give you what? 1. Those who are confused, let's solve it manually. 4 combination 0, we have 4 factorial all over 4 minus 0 factorial, and then we have 0 factorial. So this will give you 4 factorial all over 4 minus 0 will give you 4 factorial. 0 factorial is still 1. So you realize that 4 factorial cancel 4 factorial, we are having 1. So we have the coefficient to be what? 1. Easy. So we have our plus. 4 combination 1 will give you 4. So it will give you 4, and then 2 raised to the power 3 will give you what? It will give you 8. And then we have minus x. 4 combination 2 will give you 6. And then this will give you 4. And then we have minus x times minus x. Negative, it will give you positive. It will give you x squared. So this is going to be what? Positive x squared. Remember that. And then we have plus 4 combination 3 will give you 4. Should we work it? Let's try and see. So we have 4 combination 3. We have 4 factorial all over 4 minus 3 all factorial, and then we have 3 factorial. So this will give us 4 factorial all over 1 factorial is the same as 1. So we are left with 3 factorial. So 4 factorial is the same as 4 times 3 factorial all over what? 3 factorial. So you realize that this and that will go, we are left with what? 4. Very, very easy. That is the coefficient. So we have minus x all power 3. This is the same as minus x times minus x times minus x. And that is going to give you minus what? X power 3. Remember that. So we have minus x power 3. And then 4 combination 4 will give you 1. This will give us 0. So we have positive x power 4. Let's do the algebra and then let's see. 1 times 16 will give you 16 plus 4, 8, 32. So we have 32. There's a minus x here, so it will be at this very place. Then we have x. Then we have plus 6, 4, 24. X power what? 2. And then we have minus. So the minus will come to this very point. 4 times 2 give us 8. X power 3. And then we have the last one, x power 4. Very, very easy and then simple. Using the combination approach, very, very, very easy. Let's take our last example. So we have our last example. We have to expand this binomial expression using the combination approach. So first of all, let's identify our first term. So this is the first term. This is what? The second term. Our n is equal to 4. So therefore, we will be having how many terms? 5 terms. Good. So let's continue. So with this, we are not going to look at the formula. So go with me. Our n is what? 4. So we have 4 combination of 0. Our first term is what? 2x. So we have 2x. And always the first term takes the whole of what? The power of the binomial expression. So we have 4. Whilst for the second term takes a power of what? 0. So we have 1 over 2 raised to the power 0. You are good to go. You have your plus and then 4 combination from 0 we move to what? 1. The power of the first term decreases. So it decreases from 4 to what? 3. So we have 2x raised to the power 3. And then the power of the second term appreciates, it increases. So from 0, it moves to 1. Very, very easy. Then you have your plus 4 combination. From 1, you move towards 2. And then we have 2x. From 3, it decreases towards 2, while the power of the second term increases. So we have from 1, it moves towards 2. Easy, easy as ABCD. Then we have 4 combination 3, 2 raised to the power 1, 1 over 2 raised to the power 3. And then we have the last one, 4 combination 4, 2x raised to the power 0. And then we have 1 over 2 raised to the power 4. Very, very, very easy. You don't have to memorize any formula. You don't memorize. Just follow. You follow the pattern, it will come by itself. So we have 4 combinations, 0 will give you 1. You can also use the calculator to punch to find the combinations. 4 combinations 0. You can press 4 on your calculator. You press shift. And then you press the division sign. And then you press the number 0. It will give you number 1. Similarly, if you are looking for 4 combination 1, you press 4, shift, and then division. You press 1. It will give you the answer. So you can use the calculator to find your combination numbers. As easy as that. Some of you don't want trouble, you don't want problems, so you like to use the calculator. You can use that. So from the calculator, 4 combinations, they will give you 1. 2s raised to the power 4. It means 2s times 2x times 2x times 2x. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. The rest indices, when the bases are the same, they are multiplying. You pick one of the base, you add their exponents. So we have 1, 1, 1, 1, 1, 2, 3, 4. Just that, as easy as ABCD. So we have 16x power 4. Any number raised to the power 0 gives you 1. Good. We have 4 combination 1, it will give you 4. So we have 4. 2x raised to the power 3 will give you 8x raised to the power 3. And then this will still give you 1 over 2. I guess you are following. So we have plus 4 combination 2 will give you 6. We have 6. And then this will give you 4x squared. Then we are left with half raised to the power 2 will give you 1 over 4. Good. And then we are at this raw point. 4 combination 3 will give you 4. You can point it on your calculator. We have 4 and then shift. You press division sign and then what? 3. You press your equal to. It will give you 4. So we have 4 of this marker. 4, this will give you 2x, and then this will give you 1 over 8. You have plus 4 combination 4 will give you 1. This will give you 1, and then this will give you 1 over 16. Let's continue. This will give you 16x raised to the power 4. We have 4 times 8 will give us what? 32. X raised to the power 3. This multiplying half, we can write it as that. And then we have plus 6 times 4 will give you 24. X raised to the power 2. Multiply 1 over 4, we can write it as this. And then we have plus 4 times 2 give us what? 8. You have our x. Multiply 1 over 8, we can write it as what? 8. And then we have plus This will give us 1 over what? 16. So let's do some division here or some cancellation here. So we have 16 x power 4. This into that we have 16 x raised to the power 3. 4 into 24 we have 6 x power 2. And then 8 into 8 we have 1, and that is x. And lastly we have 1 over 16 as easy as A, B, C, D. And that is that. I'm going to give you some tutorial set question. You can pause the video, you try your answer them. Okay. So this is your tutorial set. See you tomorrow. Bye 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 bye.